Good. All right. So just to recap a little bit on percent composition before we do empirical formulas, we have 3 easy questions here that we're gonna do together. I'm gonna do a lot. We're gonna do a lot of it together just so we can get through it. You know, just so we can have time at the end. If you want me to grade your quizzes, I can grade your quizzes. I have them there, and we can do some ticket stuff, exchanges, grade stuff, whatever you need to do. So I'm gonna try to fly through this, but obviously in like a decent enough manner that you understand what I'm talking about. Okay. Number 1 says calculate the percent composition of the following compounds. Okay, I have the compound HCl. It's asking for the percent composition. The first thing that you want to determine is what elements are in my compound. Can you tell me?
Hydrogen.
Perfect. Hydrogen and chlorine. Those are the 2 elements in my compound. Do you remember the formula for percent composition?
The mass.
Percent of?
Mass of the element
Yes.
over the mass of the compound times the
Good. Mass of the element over mass of compound. And how do you find the mass of the element? No.
The periodic table.
No, I want to know how to get the top alone. From the periodic table, yes. The mass of the element comes from the periodic table. Or it could actually give you the value in the problem. The mass of the compound comes from where?
Adding the mass of the element.
Yes, adding the masses of all the elements in the compound, and that gives you the total mass. Okay, so let's do that first. What is the mass of hydrogen? What is the mass of chlorine? 35.45. Add these 2 up together, what do you get?
36.45.
Perfect. Okay, so then that will be at the bottom or top of my fraction formula? Right, so I have 35.45, it's molar mass, grams per mole, but the units cancel out, so don't worry about that. 35.45 at the bottom. Remember, all percent times 100, just keep that in mind. Everyone understand how I got to this point? Yes? Okay. So again, I get the total of the compound, the mass total, by adding them together, that goes at the bottom. Sorry, 36. 36. 35 plus 1, 36. Okay? Good, yes. What goes on the top of the fraction? The molar mass of the element, which we already found over here. So what's the molar mass of hydrogen?
1.
So that goes on top. And chlorine?
35.
Perfect. Okay, and I divide them both and multiply by 100. What do I get?
On the bottom, you're 97.256.
97.256. Okay, and the top? 2.74. Don't round sig figs yet. We'll round figures together. Okay, 2.743%. You're with me? Okay. Now, what did I tell you about significant figures for all percent composition? Round 2, 3 sig figs. Okay, where's the 3rd sig fig? Huh? 4. Can 3 round 4? So 2.74% is the correct answer of hydrogen. Okay, my 3rd sig fig, it's 2. Can 5 round 2? Yes, 97.3% of chlorine is my final answer. Now, do you see how this guy has 2 decimal places? This guy has 1 decimal place? They're both 3 sig figs. But if I add them together, I will not get a perfect 100. What do you get when you add them together? 100.04. That's fine. 100.04, 100.4. Sorry, not 100.4. 100.1, 99 even. So depending on the decimal places you have, you might have a little bit slightly off of 100. That's fine. But if I add them together, I get 125. That's wrong. Add them together, I get 60. That's wrong. Does that make sense? So 99, 100, 100.1, in that range. Any questions on number 1? Okay, number 2. I have MgNO3, 2. Magnesium nitrate. Okay, first step in determining percent composition is identifying the elements. What elements do you see here? Magnesium, nitrogen, oxygen. Okay? Magnesium, nitrogen, oxygen, need space. Okay? Again, if I have an element here to determine its percent comp, I'm going to have to do the formula for that 3 times if I have 3 elements. Each element gets its formula. So 3 times. Okay? The first thing I want to identify is the total mass of the compound. How can I do that again? Do what? Add up all the masses of all the elements. What's magnesium on the table? 24.31, correct?
Yeah.
And nitrogen, how much is it with? 14. However, how many nitrogens do I have? 2. So what's 2 times 14?
28.
So it's 28 that I write here. Does that make sense? Because there's 2 of them. Okay? Oxygen weighs how much? 16, but I have how many? 6. 2 times 3 is 6. Okay, so 6 times 16 gives me? Beautiful. When you add all these numbers up together, what do you get? 148 point. And then this is molar mass, grams per mole, but again, units cancel out, so it doesn't matter. This is the total mass of the compound. Okay, so each one will get their own fraction. I will put that number where? Perfect. 148.31, 148.31, 148.31. And again, all of this is multiplied by 100. Now, what do I put on the top? The mass of the element. What is magnesium's mass? We just got it. 24.31. What is nitrogen's mass? Okay, 28. Remember, if there's multiple of it, you count that into the mass. 28. And oxygen? Good. Who do you think is going to have a higher percent composition? Who do you think is going to have a higher percent composition? Oxygen. Why? Because it's the biggest number, the most mass. Yes.
I need a Kevin
Kevin? Yes. For what?
from his modality.
Sure, that's fine. He's right there. Thank you. Okay, now we divide and multiply by 100. So do that math for me. 24.31 divided by 148. For which one?
28
Good, you multiply by 100?
Oh,
Yes.
that'll be 18.8.
Beautiful. Okay, and then 96 divided by 148.31. That gives me 64.72%. Remember, how many sig figs do we want for all of these? 3. We want 3 sig figs. Make our life a lot easier. So, the first answer, how will I round to sig figs? There.
Which one, sorry?
First one. How many sig figs? We said 3. This is the third, right? Can 9 round 3? Good. So 16% of? Beautiful. Okay. Third sig fig? Can 7 round 8? 18% of? Beautiful. And last but not least, give me the final answer. Beautiful, because 2 can't round 7, correct? Of oxygen. And those are my 3 answers to find percent composition. Okay, does that make sense what I just did?
Yeah.
Perfect. Can I erase?
Yeah.
Okay, yes?
Yeah.
Alright. Here it says a chemist determines that 3.96 grams of iron reacts with 1.2 grams of oxygen to form rust. What is the percent composition of iron and oxygen? Okay, so it doesn't give me a compound here, it gives me a scenario. But same exact steps. I want to identify what elements am I going to be finding the percent composition of? Iron and oxygen. Okay, I know the formula will be the same. What goes on the bottom of the formula? The mass of the compound. Okay, well, does it give me the mass of the compound here? No. It does give me the what? Mass of the elements. Where will those numbers go? Right, so where will 3.96 go? For which one? Good. 3.96 grams of iron. This is the mass of the element of iron. You're not putting molar mass. No. It's giving us a number. You use that number. Does that make sense? And what is the mass of element here? 1.2. Now, how can I get the total? Adding them. What's 3.96 plus 1.2?
5.16.
Beautiful. Both grams and my grams cancel out. I should have nothing by my unit. Nothing by my number except for the percent unit. Right? No grams, no moles, it's just percent. Okay, when I divide 3.96 by 5.16, what do you get? Guys, come on, wake up. No one got an answer? Okay, I guess I'll do it on my own. 76.74% of iron. I know it's last day before spring break, but I need your help. Okay? 1.2 divided by 5.16, what'd you get?
0.232.
2
0.2.
times 100.
23.2.
Beautiful. Percent of oxygen. And how many sig figs for both? Good. So what does this become? 76.7% of what? Good. I don't know why that happened. Okay, 76.7% of iron. And here? Good. And add these two numbers together for me, please. What do you get? You get a perfect 100 here because I have one decimal place after the, what was this again? 76. Thanks. One decimal place after, and one decimal place after. They add up to 100. That's good. Okay. Any questions on how I solve this? Easy, right? Okay, let's make it to our next topic, empirical formula. Another easy topic. A little bit more steps in the math, but it's easy stuff, I promise. Okay? So, first let's define what an empirical formula is. Okay, an empirical formula is the simplest whole number of ratio of elements in a formula. Okay, so if you look at a formula, such as CO2 for example, and you think to yourself, can I reduce this any further? And you say no, it's empirical. Okay, can I reduce CO2 any further? Well, CO2 has one carbon, 2 oxygen. Can I reduce this by dividing both by 2 and making it lower? No. It'll give me a decimal here, and I can't have a decimal as a subscript. So this is the most reduced it can be, yes? Okay, so this is an empirical formula. Okay? However, on the other hand, look at this formula, C10H22. Can I reduce this any further?
Yes.
By doing what? Dividing by what? Both by, right, so you want to simplify the subscript by dividing by the same number. I get C5H what? 11. Okay? The formula that I had before I reduced it is called a molecular formula. Molecular formulas show us the actual number of atoms in a compound, and it is not reduced to the lowest ratio. Okay? So C10H22 is an actual compound containing 10 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 22 hydrogens all along the chain. Okay, it's an actual compound. And pretend there's H's around it. So that's the molecular formula, shows me the actual number of atoms in a formula. Okay, when I reduce the subscripts and I get C5H11, that is my empirical, my most simplest ratio. Okay, can I reduce the empirical any further? No. Does that make sense what I just said? Okay, perfect. Okay, so scientists like to use the empirical because it gives them a better idea of the ratio going on. So if I see C6H18O3 compared to C2H6O1, it's easier for me to say, okay, well, for every 2 carbons, I have 6 hydrogens. Instead of for every 6 carbons, I have 18 hydrogens. It's the same ratio, but this is more reduced to the lower number. And that's what we prefer. Okay, that allows them to compare and contrast, the amount of elements in a formula and determine, who might be the one with a greater percent composition. Any questions on this so far? Okay, so we're going to learn how to calculate percent composition. Sorry, empirical formula, using percent composition. Okay, so remember, percent composition tells us the ratio of masses in a compound. Okay, all percent is out of what? 100. So if I have 100% sample, I get, not 100% sample, I have a sample, okay? It adds up to 100%. 51% of that is oxygen here, 42% of that is carbon, 6% of that is hydrogen. Okay? Let's say I took this sample that contains these ratios and these elements, and I weighed it out to 100 grams. That would be equivalent to me saying 51.41 grams of oxygen, 42.12 grams of carbon, etc., etc. Does that make sense what I just said? Okay, same exact thing because, again, percent out of 100. So if I take a 100-gram sample of the compound, I could use the same percent because it's all the same ratio, except both out of 100. Okay, so we use this percent composition to determine the empirical formula. What does it mean to determine the empirical formula? Okay, what we are going to be trying to do here is I'm going to give you elements like N and O, for example, and your job is to find out what subscripts go here. Okay, what numbers go here? So is it NO2? Is it N2O? Is it N205? You don't know. You're going to use that, the percentages, to find that empirical formula. Okay, and it's a very easy process. So I'm going to show you an example because it's easier when I show you an example rather than no. Okay, I need you to understand something. When I have a compound, right, any compound, like Fe2O3, okay, there's 2 atoms of iron and how many atoms of oxygen? 3. 3 atoms. We also can refer to these numbers as moles. I have 3 moles of oxygen, right? 2 moles of iron. Why is that? Well, I know that 1 mole is equal to a certain number of grams depending on the element. In oxygen's case, right? In oxygen's case, what is the molar mass of oxygen? 16. So his molar mass is 1 mole is equal to 16 grams, correct? If I have 3 moles, how many grams is that? If 1 mole is 16, I have 3 of them. Do you see what I'm doing? So this is also can be, I could say it's moles. So what we're going to be doing here is converting these percentages to moles, and that will give me the number to put in the formula. Okay, so just stay with me, it makes sense. Okay, so we already established that if I were to take this percent, right, and I were to take a 100-gram sample of this compound containing nitrogen and oxygen, it would be equivalent to the grams. So what I'm going to do is I'm going to read the problem. A compound is analyzed and found to contain 25.9% nitrogen and 74.1% oxygen. What is the empirical formula of the compound? Okay, your first step is to take those percentages and change them to grams.
Well, aside from the interruption, can I put Benjamin Silva's?
Okay, and change them to grams. Again, it's out of 100. I am assuming that I have a 100-gram sample in this calculation. The ratio will be the same no matter how much my sample is. It's easier to do out of 100 because the numbers are given to us.
Can I get the one for Hillel?
Sure. Sure. Okay, so I'm starting off with 25.9 grams of nitrogen. My first step is to take those percents and change them to grams. So what should I write for the other one? 74.1 what? Of oxygen times a fraction. Okay, y times a fraction. Again, what are we trying to find? We're trying to find the numbers of the elements in the formula. How can we refer to that as? So I want to find the what here? Moles. Bye, have a good day, have a good break.
Like you said,
Mhm.
every single time, like the percentages, you always change it to grams.
Correct. It'll be given to you as percent, you change it to grams. Every time. Okay? It makes sense. Don't worry. So, again, I'm looking for the moles, the amount of each element in the compound. So I will put mole on top because I'm looking for moles. Do you agree? Okay. Well, what am I canceling out? So that's going to go where? For both, yes? Okay, grams per mole, mole per gram. What conversion factor is this? Molar mass. Nice. What is the molar mass of nitrogen? 14 what? What's the unit for molar mass? 14 grams per mole. So where does that 14 go? 14 grams per 1 mole. Oxygen? 16 what? 16 grams per. Beautiful. Okay, let's find the moles. My grams cancel out. What is 25.9 divided by 14? $1.85, yes? Guys, come on, I need you. 4.631 here. You're with me?
Yeah.
You're with me so far? This is the moles I just got. Okay, so does it make sense if I take N? Oh, I have 1.85 moles of N. And then I take O. Oh, I have 4.631 moles of O. Does that look right to you? That's not right. You agree? Everyone agrees? Good. Okay, we want to reduce this to the lowest ratio. Why? Because we're looking for the empirical formula. What's the definition of the empirical formula? Lowest ratio. So I am going to divide these by, what do you think that will get me to the lowest ratio? That will get me to one of these numbers becoming 1. Perfect. I will always divide them by the lowest, smallest number. So out of these two that I just found, which one's smaller? So I'm going to divide both of them by that small number. By doing this, it causes my ratio to be set equal to 1. Because this turns into 1, and this turns into 2.5. Do you see how now my ratio is 2.5 to 1? It's easier to visualize than this. For every 1 mole of nitrogen, I have how many moles of oxygen? But does that look right still? No. Yes.
No, you said there was no decimal.
Correct. It doesn't look right. It's not correct. Everyone agree?
Yeah.
Good. Okay, so now we have to do something very simple where we look at the number, that's the decimal, and we think to ourselves, how can I make it whole? What can I multiply this by to give me a whole number? By 2. If I multiply it by 2, what do I get? What if I multiply it by 3? Is that a whole number? No. How about 4? 10. But is that the lowest ratio I can go? No, the lowest is 5. But if I multiply this guy by 2, I have to multiply that guy by 2 also, because why? They're a ratio. Does that make sense? Now I have 2 here. Are both of these moles whole now? Great. So how many N's do I have in my formula? How many O's do I have in my formula? There is my final answer, the empirical formula of the compound. Does that make sense what I just did? Those whole numbers tell me how many of each compound, how many of each element I have in the compound. Don't worry, it's gonna make sense, I promise. Okay, so first step, took the percentage and did what to it? Turned it to grams. Then took the grams and changed it to moles. Then took the moles and divided by smallest numbers. Then took took the answer and made it a whole number, and there's my final answer. That's it. Can I erase this? Okay, let me show you another example, better example. Okay, for this question it says a compound, so this one you're going to do on your own, not now. This one we're going to do together because there's more numbers. Okay, a compound that is 40.5% zinc, 19.9% sulfur, and 39.6% oxygen. Okay, my first step, what should I do? I want to find the empirical formula. Change the percentages to grams. So I will rewrite this. This is my first step. Take each number and put grams. 40.5 grams of zinc. Okay, what's next? 19.9 grams of sulfur. And 39.6 grams of oxygen. And what am I doing with these grams? Beautiful. So I'm multiplied by a fraction so I can convert them to moles. You're with me so far? Everyone is with me so far? Okay. I'm looking for moles, so where is it going to go in the fraction? On top. For all of them? Yes. And what am I canceling out? For all of them? Yes. Grams per mole, mole per gram. What conversion factor is this? Molar mass. Molar mass. So what is the molar mass of zinc? How can I find that? Good. And where'd you get that from? Perfect. And where will that number go? Bottom. 65 point, what you said?
38.
Grams per 1 mole. And this one? Sulfur? 32.07 grams per mole, and oxygen is 16 grams per mole. Okay? Now all I have to do is solve it and calculate. Okay, I have 40.5 divided by 65.38, and you get 6194. Okay, it's 4 6 figures when you round this answer, and you'll see why in a second. Preferably. The more numbers you have, the more accurate your answer is. Okay? So remember, we want to divide by the smallest number, yes or no?
Yeah.
Okay, so let's say I didn't write any of this. I only write the first 6 figures. How would I know which one's smaller? You know what I'm saying? So you want to write as many numbers as possible to determine that. I say 4 every time because it makes the calculation much simpler and more uniform. Okay, so it's 2.475. So you see how all of these are 4 sig figs. Because why? Leading zeros don't count. Okay, 4 sig figs, 4 sig figs, 4 sig figs. Okay, what should I do next? Divide by the lowest number. What is the lowest number? The first one. This is smaller than this, yes or no? So divide by 0.6194. That gives me 1. This also gives me what? Tell me in the calculator. I'm dividing all of them by the smallest number. You're with me? Now this is where we're allowed to round. We are allowed to round at this part. After I divide by the smallest number, I can now round. The 2.5, not allowed to round. Only 0.9 you can round and 0.0 you can round. So What is that when I divide? Come on, all of you have calculators on your desk, and you're just staring at me like I'm speaking Chinese. Come on.
1.0017.
Say it one more time for this one.
1.00.
Perfect. 1.00. That's what I need. Thank you. Next.
3.99.
Perfect. 3.99. What can I round that to? Perfect. It's never going to give you a perfect number, by the way, because look at the decimals we're dealing with. So, do all of my answers, are they all whole numbers? Great. So now, I will take the element. What's the first element? Zinc. How many do I have?
1.
Okay, I leave it. I don't write anything, right? Sulfur. How many do I have? Do I write anything? Oxygen. How many do I have?
4.
Zinc sulfate, ZnO4. That is the compound we just calculated. That is the empirical formula for this problem. Does that make sense what I just said?
Yeah.
Good. Do number 1. Easy, right?
Yeah.
I'm like, where's my phone? Oh, there it is. Hold on. Yes, take it till you come to the board. I mean, you come to my desk. Hey, what's up?
Lucas told me to get a spring break packet for me because he's not at school.
Yes. Thank you. What time is it? 9:44. We're doing good. Everyone should be attempting. So this is what your packet's going to be on. So I want you to know how to do it in class before you leave for spring break and have no clue. And then cry to me on Sunday night. You say I don't understand. Two 256 gigabytes really coming in close today.
Can we just round it to whole number?
Yes. So you're allowed to round 0.9s and you're allowed to round 0.0. If you get 0.5, 0.3, anything like that, 0.8, 0.7, then you have to multiply by a number and make it whole. Does that make sense?
Yeah.
Perfect. Nice. Yes, good job. Excellent. We're green, right? Yeah. You guys just don't listen, huh? Yes, good. No wonder. Perfect. Excellent. You're welcome. Where did F come from? What does the problem say? Okay, so then Fe is iron, that completely different mass, completely different numbers. It happens, don't worry. Perfect. 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 Take a beer. Blood orange. It's really good. It's weird looking though, right? It's red. What'd you get? Excellent. Get it together. Almost there? One more minute. So you can't have percent grams. So 37, 34. 34.8 grams of iron. Good. 65.2 grams. Not percent point. One at the bottom. One at the bottom. Good. You can buy your mom. Yeah. So this number right here. 65 divided by 35 is not what it is. So that number is wrong. So then just double check your calculation here and then redo it. You got the right process, just the wrong number. Next box, you. Is that me? What? The water? Yeah. Stop. I'm so sorry. Excellent. So sorry. Excellent. Okay. Can I go? Can I do it?
Yeah.
Time to think about it. All right. So look at my problem. What does it say? A compound that is 34.8% iron and 65.2% chlorine. Find the empirical formula. Right? I know that my first step is to take my percents and do what with them? Convert them to grams.
Is this what the fact was about?
Say it again?
Is this what the fact was about?
Yes. And the percent concept we did last time. Okay? And I gotta do what to these numbers, guys? Change it to moles. Where's the moles gonna go? And what's on the bottom? Grams per mole, mole per gram. What conversion is that? Good. And how can I find the molar mass of iron? Which is? 50?
5.85.
Thank you. Grams per mole. And then? 35.45 grams per mole. Okay? That number, when you divide, gives me what? 6.3. Oh my god. Can't write. Perfect. And this one? 1.839. Good. 2, 3, 4 sig figs, don't round it. Because if you round mid-problem, your answer's going to be wrong. So I just look at my calculator. If it gives me a long number, I write the first 4. That's all I do. Good? Obviously, 0 is not significant. Don't count that as a number. Okay, now I have to do what with these two? Divide by the smallest, which is? What does that give me when I divide them?
That gives you 1.
Good. And this one? 2.9. Are we allowed to write around 0.9s? Yes. To what? Beautiful. 1 and 3.
2.8.
No. You have to multiply by a whole number. But you shouldn't get 2.8 on any of the problems that I gave you. Mine will be very straightforward. Okay? So again, both of them are whole numbers. Can we agree? Now I can take these and put them in my formula. So how many iron should I have? 1 Fe, but I don't write the 1. And how many Cl? 3. Okay, my compound is FeCl3. Does that make sense?
Yeah.
Good. Easy?
Yeah.
Okay, can I erase it? Good. Now we're going to do molecular formula. We're done. It's like 2 sides. It's the easiest thing. You thought that was easy, it's easier. Less steps. Okay? Before we do that, I want you guys to real quick tell me, without looking at this, CH, is it empirical or molecular? How do you know? Right. Can I reduce it? No, so it's empirical. Ethene, C2H2. Can I reduce it? Yes, so it's beautiful. C6H6, can I reduce it? Yes, so it's molecular. Can I reduce it? No, so empirical. It says also molecular because both of them are the same. You wouldn't know that unless you knew the formula of methanol, so it doesn't matter. Okay? Ethanoic acid, C2H4O2. Molecular because I can reduce it. And this guy? Molecular because I can reduce it. Okay? Does that make sense? So now we're going to solve for molecular formulas. Very easy. Okay? I'm not going to read any of this. I'm just going to show it to you because it's that easy. Calculate the molecular formula of a compound whose molar mass is 60 grams per mole and the empirical formula is CH4N. I need you to write this down. Put a star next to it. Highlight it. Red pen, purple pen, whatever you need to do. Ready? You cannot find the molecular formula unless you have the empirical. You cannot find the molecular formula unless you have the empirical. Does that make sense what I just said? What is this question asking us for? Good. Do I have an empirical in the question? It gives me an empirical formula? It gives me an empirical formula?
Oh yeah.
Yes. What is the empirical formula? Perfect. What makes it empirical again? I can't reduce it, right? Okay, so my empirical formula is what? CH4N. Does everyone see that the problem gave it to me? So now am I allowed to find the molecular? If it did not give it to me, I would have to find it first. Does that make sense? Okay. So, there's two things you need to solve this problem. You need the molecular formula, molar mass, and you need the empirical formula, molar mass. Two things. That's it. Okay? It gives me a molar mass in the problem, correct? Which one do you think that is? Yeah, is it molecular or empirical? Molecular. Okay? Well, what is it asking me to find, guys? So, can I find the molar mass of a compound without the compound? No. So it has to give me that. Okay? So when asking for the molecular formula, it must give us that mass. We don't know. So my molar mass is 60 grams per mole. You with me? Can I get the empirical mass? Yes, because I have the formula. So how can I find the empirical mass when I'm given the formula? Well, C is what? What's the mass of carbon on the periodic table? Plus, what's the mass of hydrogen? 1 times 4 is? Plus, what's the mass of nitrogen? What is 12 plus 4 plus 14? Plus 14? 30 what? Grams per? Good. So now do I have the molar mass of the empirical? Yes or no? Good. I have the molecular, I have the empirical. Molecular is given to me in the problem. Empirical, I get. I calculate myself. Next step, divide the two numbers. This is the formula. Molecular over empirical. What is 60 divided by 30? 2. I'm going to take that 2. I'm going to take my empirical. I'm going to multiply everything here by 2. So what does the C become? What does the H become? What does the N become? I'm done. There's my molecular formula. Thank you. Thank you very much. Have a good day. Does that make sense what I just said? Easy? Can I erase this? I have 2 more examples we're doing together and then we're done for today. Okay. No questions. I can erase it. No? None. Why can't I feel this orange? It is easy. I agree. Oh God, you're really making your face mess in the world. Ready? All right. Of course, Ms. A's a meanie head. She's never going to give you an answer to a question so easy like that with all the information. So let's look at number 1. A compound that is 54.5% carbon, 9.1% hydrogen, and 36.4% oxygen. Okay? we want the molecular formula of that compound. The molar mass is 88 grams per mole. What is the molecular formula? What did I make you write down in star and highlight and put on in different colors? You cannot find the molecular formula without the. Am I given the empirical here? No, but I am given percentages. I can use those percentages to do what? So find the empirical. An extra step, but it's not bad. Okay, let's begin. So what do I do with the percentages? 54.5 what? Of? Times? Fraction. Excellent. Times the fraction. Okay? Good. 9.1%. Sorry, not percent. Grams of. And then I have 36 point. I shouldn't do it like this actually. I'm gonna have no space. I'll put it here. 9.1 grams of hydrogen, and then I have 36 point grams of. You understand how I'm writing it, right? Yeah. Okay. So I got each percent and I changed it to grams like I'm supposed to. Now what should I do? Right, I'm looking for moles, put moles on the top. Looking for moles, put moles on the top. Looking for moles, put moles on top. What should go on the bottom? Grams. What do I need? What numbers go here? Molar mass. How can I find the molar mass? Where, what's the molar mass of carbon? 12 what? 12 grams per hydrogen, 1 gram per mole. Oxygen, 16 grams per mole, correct? Help me divide these numbers. $54.5 divided by 12 is what? 4.5. Everyone got that? Okay. And then for hydrogen is obviously just 9.1, and oxygen is just 2.275. See how this one is just 2 sig figs? It's fine. That's what we're given. That's what we have to deal with. Everything else should be 4 if I have a say over it. Now we divide by the smallest number, which is? Divide this guy by 2.275. This gives me 1. Divide this guy by 2.275. This gives me 4. What was the answer in the calculator? 4. Exactly 4? Yeah. Nice. 4. Makes your life easier. Divide this guy by 2.275. What does that give me? 1.99. Can I round to 99? Yes. To what? Perfect. So how many C's do I have in my formula? 2. How many H's do I have? 4. How many O's do I have? 2. Perfect. And what is this formula we just found? Empirical. We're not done yet. This whole thing was just for the empirical. We need to find the molecular formula next. Does that make sense? Yeah. Remember, last question, we were given it. That made our life easier. This is not, it doesn't give it to us, we have to find it first. You can't find molecular without empirical, right? So, can I erase all this? Yes? Okay. Someone said no? Oh, they said no. Okay, so C2H4O is my empirical formula, yes? Wait, C2H4O, yes? Okay, so now I have my empirical. Yes? So what should I do now? I need to find the molecular. I know the formula is molecular formula. I'm going to say MN is molar mass, because I don't feel like writing it. Molecular formula, molar mass, over empirical formula, molar mass. The one given to us in the problem must be who? Because because in order for me to find molar mass, guys, I need the formula of the compound. I don't have the molecular formula. I'm looking for it. So will I know the molar mass of it? No. So it must give it to me. So molecular formula molar mass is 88. Okay? By the way, sorry, I'm going to say this after. Let's do this first. Empirical formula molar mass. How can I calculate that? I found the empirical. It's calculated. C what? C is what? Okay, times, okay, plus, beautiful, 24 plus 4 plus 16. Where is that going to go? 5, right? So the grams per mole cancel out. What does this give me? 2. Do you see how every time I'm going to get a nice whole number? Okay, if you don't get a whole number, you did something wrong. You probably put the numbers the wrong way. Always, 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 always a whole number. Okay? Good. 2. So then now what do I do with that 2? I multiply all the elements for my empirical formula by 2. So this carbon becomes, H becomes, and O becomes? Am I able to reduce this? Yes. So if I'm able to reduce it, it's an a molecular formula. It gets reduced to the empirical that I already found. This is my final answer.
So we put it like, you don't reduce it?
No. If it's asking for molecular, do not reduce it. Any questions on how I just did this one? Okay, you're going to do number 2, and we're done for today. When you're done with number 2, bring it to me, I'll give you a ticket.